How's it going, guys? Welcome back to the ThermoDiet podcast. I'm your host, Jayton Miller, and I am here with Keith Littlewood. How are you doing, Keith?
I'm not too bad. The lockdowns have just eased up where I am here in the Middle East. So I went for my first walk today in a long time. So I feel quite free, shackled free from my prison cell of home.
Heck yeah. So for the listeners who don't know Keith, can you kind of tell us your background story and how you got here?
Sure. I went into the army when I was a teenager for about 4 years, primarily because I didn't have an idea of what I wanted to do. And then I came out, gradually fell into coaching and fitness and gym. And then I ended up working for a couple of PT companies, then setting my own gym up and personal training company. And I kind of moved away from those in 2005, kind of realizing that I really enjoyed becoming more of a clinician and understanding some depth around human physiology. So I did a basic degree in fitness and health. And at the same time, I was studying a variety of things like functional medicine, neuromuscular therapy. And then around about 2009, 2010, I found Ray Peat's work, which really challenged my bias on a few things, especially from the functional medicine perspectives. And I guess then since around about 2016 to 2018, I did a postgrad and master's degree in endocrinology, which was kind of looking at the accuracy of thyroid hormone evaluation in the face of mounting pollution and stress and all of these things that perhaps make analyzing thyroid physiology and making an accurate diagnosis quite problematic. So that's where I am now, and I kind of work with people on coaching people to do, energetic issues, sleep, digestion, fertility, that kind of thing. And that's what I kind of do now, and hopefully going off to do some more studies at some point as well.
Definitely. So one area that I really liked your kind of perspective on and the way that you talked about it was TSH and just regular thyroid hormone testing. So can you kind of give us some of the nuances that are there and some of the most accurate ways to test thyroid function?
Sure. I think, the basic premise of thyroid physiology, we have a thyroid gland which produces T4 and T3, and most of T3 is kind of produced systemically around the body, liver, kidneys, musculoskeletal tissue, that kind of stuff. And when there's not enough thyroid hormone being produced, classically, the pituitary produces TSH, or thyroid stimulating hormone. Now, this is all well and good in your classic endocrine feedback loops, but what you can see, and comes out in a lot of studies, and even going back nearly 80 years ago to Broder Barnes' work, where he was looking at aspects of thyroid health like Walkman signs, the Achilles tendon reflex, cholesterol levels, and your basal temperature test to look at whether someone's thyroid hormone is working efficiently. Now, modern lifestyle, a large swathe of populations live in urbanized areas. They live in areas that are quite stressful, far removed from some of the rural aspects of being in nature, being around relatively clean air, and also exposed to other pollutants like electromagnetic frequencies, which are increasing. Now, if you look at the literature, and there is quite a large body of literature that shows that pollution tends to muddy the waters on an accurate thyroid physiology. So when you go to the doctors and present with your whatever symptoms they are, your clinical presentation, which could be digestive issues, sleep, fertility, energy, weight, either gain or inability to gain weight can be an issue related to thyroid hormone, and all of the other stuff, because thyroid physiology permeates every single aspect of function in the human body. But then the doctor will run a blood test, and this blood test will generally look at TSH and T4. Usually in the free hormones, which is another subject in itself. But even a lot of physicians would just look at TSH. The thyroid stimulating hormone is essentially a stress hormone. It's produced when the body doesn't actively convert T4 to T3 throughout the body. So if you're in a high pollution area, the chances of you having problematic feedback loops are quite high. For example, we have this soot from combustion engines, coal fires, and other things. Coal fires probably not as prevalent as they were, 20, 30 years ago or 50 years ago. But certainly combustion engines, soot, and exhaust fumes are very, very prevalent. Now, these can have many different effects on the thyroid carrying proteins. Transthyretin is one, thyroid binding globulin, and then we have albumin as well. But typically transthyretin. Now, some people will say that any of those three carrier proteins aren't in themselves important because you could get by. They've had knockout mice where they've had knockout mice without transthyretin or thyroid binding globulin. Albumin might be more problematic because physiology, whether it's rodent or human physiology, definitely requires adequate albumin. But this could be problematic in itself, especially when we see thyroid binding globulin and transthyretin, these two quite substantial carrying proteins, tend to be hijacked by pollution. So, for example, PCBs, dioxins, the polycyclic aromatic hydrocarbons in these soot engines, and even unsaturated fatty acids combine to the thyroid carrier proteins, which means that the presentation of the blood test can be completely at odds with this clinical presentation of someone's thyroid physiology. So the clinician will go, it's not a thyroid issue, it must be something else. And then they start going down the rabbit hole of single source medications. So you never expect thyroid physiology to follow this linear path of degradation. You don't just get high blood pressure, high cholesterol, altered blood sugar levels, digestive system like constipation, altered neurotransmission. They don't all kind of occur in this nice package where you're hypothyroid, you're euthyroid or normal thyroid 1 minute and then hypo the next. It's kind of like it's a bit like being in a stress state, and Hans Sellier's general adaptation system, where you have the stress and then you come back down, you get used to it, and you can do that for so long. Well, that's thyroid physiology as well, because in a normal healthy system, as TSH increases, this stress backup hormone for thyroid, so does cortisol, and you'll keep going through these peaks and troughs until one day it becomes more overt. So there are probably tens of millions, maybe even hundreds of millions of people throughout the globe that keep going bubbling under in this subclinical state that's really hard to pick up. And the pollution, the stress, under eating for a lot of people, and many other factors, including inheritance, could drive these issues. And it's really hard to pick up an accurate diagnosis of thyroid dysfunction, and particularly hypothyroidism.
Okay. So what are some of the more accurate ways that we can test for that subclinical hypothyroidism?
Well, not necessarily accurate, but certainly what's always been described as a crude but fairly indicative test is body temperature and pulse rate. And there can certainly be many nuances around this. For example, if somebody's in a low thyroid state, we know that their ability to, one, assimilate nutrients is often decreased. Two, to increase or to adequately promote the conversion of T4 to T3 is decreased. And therefore, the energetic uptake of nutrients and the ability to regulate body heat via thyroid metabolism and thermoregulation is substantially decreased. So we know that body temperature will be low in low thyroid people. Now, most mammals regulate their temperature quite well around 37 degrees. Now, hypothermia, for example, generally kicks in at around about 35 degrees. And again, when we start to our body temperature to decrease by about 2 degrees, we're starting to head to a state where our enzymes aren't produced efficiently and they don't function efficiently in this low body state. So using temperature as a marker is quite a valid marker of how well your thyroid's doing. There can be other nuances around that. For example, if you're stressed out and you've been in a chronic state of stress, your body will respond because as it goes towards hypothermia, it will increase the uncoupling proteins, particularly something called uncoupling protein 2, to increase thermogenesis by using brown adipose tissue. So these stored fats will increase the body's heat because the body just doesn't like to go below 35 degrees. And you'll often see people who are in a bad state, their body temperature can be around about 34.5, 35 degrees sometimes. So they're kind of bordering on that. And depending on how chronically stressed they are, will dictate whether they're running off more of the stress hormones like adrenaline, noradrenaline, cortisol, and a few other things. So if someone's been running, let's say, even if you've been running off a low-carb diet, you haven't been sleeping that well, you're under emotional stress, or even any form of stress, chemical, physical, emotional, then your body temperature will be stuck in this kind of anti-hypothermic state. It doesn't want you to be cold. So it will increase the stress responses. And it's usually when you lower the stress responses by giving people adequate nutrition, taking away the emotional stress, putting someone in a work environment that's a bit better, or even taking away any form of stress, can then actually allow the body to be present in its really where it should be, to show you where it's really at. So you can take someone from a stress response into an area where the body will actually say, I'm actually in a very low energy state, but I was running off the stress hormones. And so then you can get a better idea of where the body temperature is to, sorry, I'm just going to plug my phones on again. Then you'll have a better idea of where the body is from a temperature perspective, for example. So body temperature is crude, but it's a really, really effective way of diagnosing where the metabolism and thyroid is actually at. I don't know if you've ever read the website. Is it Mary Shomon, Know Your Thyroid?
I have not.
So she talked about a doctor called Dr. David Derry, who was a Canadian physician who was struck off the medical register for treating people's symptoms. His argument was that when if you just use TSH alone, it would take months, even longer than that, for someone's presentation to actually show you where it's at, and the TSH be of value as a good biochemistry marker for thyroid function. So he was just saying, I'm treating the symptoms. I'm seeing, digestive issues, fatigue, brain function, mood-related stuff. It resolves when I give adequate thyroid hormone, and their body temperature increases as well. Well, obviously, that was quite contentious. And you've also had that in the UK with another doctor called Dr. Barry Peatfield Durant, who did the same thing. And I think the problem is that there seems to be this need for people to, make sure that blood tests are the gold standard, but they're not the gold standard. And I can list at least 10 different reasons why the TSH would appear completely normal when the thyroid can still be depressed. And I think that's really problematic. You can back that up with the pulse rate, because, for example, bradycardia or low heart rate is a well-known symptom or marker of low thyroid state. The heart's slower, the blood becomes it becomes thicker, it's harder to pump around. This is where you'll start to see issues related to arterial inflexibility. We'll start to see blood pressure increases, and all of these things that are associated with reduced cardiac function. So pulse rate could be anywhere. I mean, even in some of the studies, it suggested that even up to 80 beats per minute, the heart can still be in a low thyroid state. Why? Because the heart rate on its own in isolation doesn't tell you anything. And if you're still running in a stress state, your heart rate could be 80, 90 or 100 beats a minute and still be hypothyroid if you're stuck in a significant stress response and don't have enough food or fuel available. So the heart rate can be really, really, really useful. And looking at the concept of the staircase effect is that the heart is actually more efficient when it beats more regularly. So if your heart rate is super slow, the chance of it having a more of a dysfunctional effect, like an atrial fibrillation or skipping a beat, can be increased. But when the heart beats on a regular basis between 70 and 85 beats a minute, this staircase effect is more pronounced, and therefore it's a bit like Albert St. George's function produces structure, and structure builds function. I think that was the right one. I can't remember exactly. But you can see that when something works in its best working order, it can give the best available response on how it should be functioning. So this is why perhaps a heart rate of between 70 and 85 beats a minute is the most beneficial heart rate that perhaps is promoted with longevity as well. Now, there are various nuances with that need to be looked at. So a lot of people, when you go and look at a lot of studies, they'll say that high heart rate is associated with increased mortality for each 10 beats above 80 beats per minute. Now, that is probably true when the heart rate is excessively above 80 beats a minute, 90, 100 beats a minute. You can probably suggest that someone's running off failing physiology, they're running off more cortisol, more adrenaline. The heart rate has to run off these stress hormones. So you have to look at the context of the person to understand where their heart rate is within an aspect of health or fitness. And fitness is a different kettle of fish, because we know that as the heart adapts and the demands from a sporting perspective, there's a threshold when that doesn't necessarily correlate with the health of someone. So I still think that an athlete still could be able to have a good healthy heart rate between 70 and 85 beats a minute if they have the right amount of fuel, if they have the right regenerative and downtime from the sport as well. It doesn't necessarily mean that they will have a low heart rate. Now, if you're involved in lots of cardiovascular exercise, you will have increased ventricular size, you will have increased cardiac output, but it doesn't necessarily correlate with increased health. And that's why with long distance runners, you can still see as much arteriosclerosis, hardening of the arteries, calcification of the arteries that's associated with somebody who doesn't do as much long distance running. So it's the context of heart and temperature. There are these kind of sweet spots, and I think 36.5 degrees on waking for temperature, 37 degrees after a good feed, so an hour after or so, and then an optimal heart rate around about 70 to 85 beats per minute as well.
So whenever it comes to cardiac function, how do you kind of incorporate the perspective of unsaturated fatty acids into that? Because I've seen studies where they've actually examined the hearts of chickens, and the unsaturated fatty acids actually inhibited the proper action potential to take place across the heart rate, across the heartbeat, and it caused like arrhythmia and stuff like that. So what is kind of your definition of how that works?
Well, I think you only have to look at the pathology, and it's well known that in obese and cardiac compromised individuals, there are often very high levels of the unsaturated fatty acids, particularly DHA and often EPA as well. Now, a lot of people, put this on a pedestal that say that these fatty acids are heart healthy or heart protective, and that's usually based more than the relative risk that exists within those parameters. So I think it's a faulty narrative that when you take, say, fish oils, for example, the risk that's often managed within the algorithm is because it reduces LDL, decreases triglycerides, that's supposedly heart healthy. But there are some connotations across cardiovascular function that are completely at odds with what's going on there. So you have to look at the studies where you're looking at actual risk versus actual events. Now, we know that, for example, these high levels of the unsaturated fatty acids like DHA incorporate into something called cardiolipin and the structure within the cell, particularly of heart tissue as well. So a lot of people consider that when you put these unsaturated fats, when you go a little bit deeper, you're looking at what's going on at the cellular level and the cell membrane. So these oils like DHA are so unstable, they decrease the function of the cell. They decrease aerobic efficiency at the electron transport chain, and they're well known to uncouple mitochondria as well. So if you have this wasteful production of energy, i.e. less ATP being produced, less efficient aerobic metabolism, progressive chronic use towards glycolysis, you're going to see cellular death and apoptosis of cardiac tissue as well. So it's really looking at what the long-term effects are. Short-term effects of these fish oils can appear, and other unsaturated fatty acids can appear very, very beneficial. But you have to look at what's going on at the, say, 6 months and years and beyond that, and also take out the other data that's confounding it. So if you're seeing increases in ceramide production and increases in thrombosis, is what you can actually see with long-term DHA supplementation. These are the nuances you have to look at before you're saying, fish oils are heart healthy and heart protective, because they might appear from a risk perspective, but the long-term use doesn't seem to clarify that position. Did that answer your question, or did I digress slightly?
No, it did. So whenever you look at the unsaturation process within the cell, or like what these fatty acids do in terms of energy production, what are some of the ways that, besides eliminating the intake of the polyunsaturated fatty acids, that you can do to promote that energy production again and allow for the electron transport chain to kind of establish its normal function again?
Well, I think that there are a number of things that can be done. The first is having adequate carbohydrate in the diet. When you have more adequate carbohydrate, you produce more carbon dioxide. More carbon dioxide means that there's more oxygen available to dissociate from hemoglobin. Therefore, the electron transport chain tends to be self-fulfilling. Diets that are at low carbohydrate or they're ketogenic, these are problematic because the peroxidation of the fatty acids tends to be problematic and what degrades the electron transport chain and ultimately aerobic physiology generally. I mean, they have some similarities with estrogen and pollutants, is that long-term utilization of fatty acids as a fuel degrades this mitochondrial function. You get more proton leak, you get inefficient production of ATP, not enough carbon dioxide being produced, and therefore you don't produce enough ATP. And the damage that goes on also creates more damage. You start to see glutathione depletion, which is that very beneficial antioxidant as well. So adequate carbohydrate production is one. Maintenance of thyroid hormone is enough. So remember, we talked about how transthyretin is a carrier for something called T4. Now, if there's not enough T4 available, there generally won't be enough T3 available, because T3 is utilized at a much higher rate than T4. And having enough carbohydrate in the diet can help to promote adequate thyroid function as well. Were you looking at other like novel things, or just the general kind of things that you can do? Because obviously things like methylene blue can help to restore the electron transport chain as well, particularly where it gets damaged, which is at that 4 and 5 complex, where cytochrome C, that last point of the aerobic chain, tends to be lost to things like carbon monoxide, oxidation of fats, not enough light available. So methylene blue is another way of restoring the electron transport chain, in addition to having enough carbohydrate available, keeping the fatty acids low, and a variety of other things.
Now, does methylene blue act as an electron donor in that case, or is it taking electrons away?
What you need to consider with methylene blue is, I don't know the answer to that question, to be honest.
Okay, because one of the kind of interpretations that I've heard is it basically plugs the holes within the mitochondria so it doesn't leak as much. Is that kind of accurate?
Actually, it's an acceptor.
Okay.
I think I need to go back and look at my methylene blue notes. It's not something that's keyed up in my brain right now. When you start to use unsaturated fatty acids, they would create more membrane permeability, and it's one of the misconceptions about fatty acids and membrane permeability. But it's well known that what's shown is that when you use the unsaturated fatty acids, even though there's this concept of permeability, they stop ions crossing the membrane. Now, the membrane, how it crosses, is open to interpretation. Whether you're a fan of the chemiosmotic theory and the membrane pump theory, which is where Gilbert Ling's work has been shown to be a general refutation to that theory, and it hasn't been unproven that Gilbert Ling's work is wrong. So what he's always said is that the aspects of permeability may actually just come from the interactions of cholesterol, proteins, the hydrophilic, which is obviously the water-loving, and the hydrophobic interactions between that, rather than the fatty acids. I think what methylene blue does per se is restore that electron transport chain. With regards to permeability, I don't know, but what unsaturated fats will actually do is make the actual membrane leakier, and you'll start to see things like sugars and other aspects of the cell start to leak out. It doesn't necessarily make it more permeable. It just increases the amount of damage that's going on in the cell. Does that make sense?
Yes, definitely.
Yeah, I don't know the answer to methylene blue if it plugs the holes, but it certainly will restore the electron transport chain. And if there are fatty acids that are also being used in this disruptive cycle that's breaking down physiology, it's having a double whammy effect of decreasing aerobic metabolism and increasing the leakiness of the cell itself. So it makes sense that it might do that as well.
Okay, interesting. So kind of going back to the thyroid discussion, whenever it comes to autoimmune issues, what are some of the common things that are happening there?
So within thyroid physiology, the common thing is that it's the same thing with any autoimmune disease as such. So typically when people are diagnosed with a thyroid autoimmunity, they're looking at the TPO, the thyroid peroxidase, or what's called the anti-TPO. The other one is thyroglobulin, which is another thyroid carrier. Remember, we have 3 thyroid proteins, which is thyroglobulin, which is inside the cell, and the thyroid itself. But then we have transthyretin, thyroid binding globulin, and we also have albumin. So the idea that when somebody has an autoimmune thyroid issue going on, they also are being attacked by the body not recognizing self from non-self. I'm not a big believer in that, from looking at the works of Jamie Cunliffe and Polly Matziger with the danger theory and the concept of morphostasis, which is basically the body's concerned with keeping it running in its best working order. What tends to happen is when there's real damage being produced, instead of the body actually attacking itself like we think thyroid antibodies are attacking thyroid tissue and structures, all it's really doing is removing tissue that's been damaged, so potentially it's not available for other microbes to use it as a fuel. And that makes quite a lot of sense to me. And I have seen quite a few clients that have been diagnosed with an autoimmune thyroid issue. When you improve their energy intake, when you give them adequate light, you often see these thyroid antibodies decrease to below 0. Now, I think that's really important to consider, that if you're in a high polluted state, if you're under a lot of stress, if you're constantly running off fuel, such as running off lipids, running off a low carbohydrate state, you're not able to regulate the aerobic chain as much as you can, and you're not able to regulate the thyroid as much as it can. So it makes sense that these structures and proteins are going to degrade. So instead of saying, hey, this person has an autoimmune thyroid issue that doesn't recognize its own body tissue, it seems more commonplace and invoking, Occam's razor, that the simplest explanation is usually the most pertinent, that the tissue, the antibodies, is just removing damaged tissue so that it's not problematic for any potential microorganisms that might be causing damage. So if we look at it that way, and then we see people lower the amount of damage that's being induced to certain structures, I think the antibodies will naturally lower anyway. So that's more one of the common things I see with the issues like thyroiditis, Hashimoto's. Graves might be a little bit different sometimes, but again, with hyperthyroidism and antibodies being produced, it could be just literally that the fuel that someone's running off, and whether they're running in a stress state or not.
Okay, so whenever it comes to the light exposure, do you typically use red light? And then do you think that it's those regenerative processes that allow for that tissue to kind of come back alive, in a sense, that downregulates the autoimmunity?
Yeah, I think it's a useful thing to look at. If you look at Albert St. George's work, when he was looking at methylene blue originally, he was saying that you could poison the whole of the aerobic chain from complexes 1 through to 5, where you get the production of ATP, carbon dioxide, and water. And he said he could restore it just by simply putting methylene blue into the system and shining light on it. So we can use light. We can use light on its own, or we can use restorative agents like methylene blue. I think light is obviously twofold. We have the spectrums of light like red, orange, and yellow, which seem to be very protective. even we could argue that getting enough ultraviolet light and adequate vitamin D can be part of that restorative process. So I think it's a combination of getting all spectrums of light, which will also, make tissue more organized and not be potentially more prone to damaging. And that's why I think that you've got to look at the person and what they're needing. For some people, it might be more light generally. Some people might need a combination of more light with changes to their diet, changes to their environment. It's not like, sometimes we look at some of the work that, say, Ray Peat has offered and say everyone will take everything on board. They'll try to increase carbs, get light, take on more vitamin D, take on more pregnenolone. And it's like, when you start to overwhelm the body with all these things at once, you have to be quite specific about what that person actually needs. So context is key with everything. And I think for everybody, starting off with adequate light is a no-brainer every single day. There's no doubt about that. And it also probably ties into some of the things that we're seeing from the coronaviruses and why people at the kind of latitudes around the equator tend to having much less issues with immunity compared to the countries that have just spent long months of winter in long days of darkness, more of the stress hormones being produced, more lowered immunity, and obviously more lowered thyroid with that, from my point of view. And that's why you're seeing a lot more people who are susceptible at these latitudes who have come out of the winter months or in spring now.
So can you kind of elaborate on the seasonal stress response that the body has and kind of like the decrease in thyroid hormone production that we have during the wintertime due to certain environmental aspects, and then how that kind of we come out of that during the warmer times?
Yeah, so typically when we start to get long days of darkness, we'll typically be exposed to more melatonin. We know more melatonin comes in as it gets dark. It's a hormone that's there to kind of put you into sleep. It's not, interestingly with melatonin, it's not actually something that's looked at from a lot of sleep biology, because a lot of sleep biologists will look at hormones like adenosine and GABA, which is the hormone that sends you to sleep. But melatonin has an effect because it is stimulated by darkness. So whether you're in winter or whether you're in forced darkness anyway, somebody who prepares to stay at home, the fact that you're in kind of darker environments will produce more melatonin. And there's a theory that wearing sunglasses stimulates the production of melatonin as well, especially if you're covered in clothes and you're wearing sunglasses. So melatonin and serotonin will generally increase, but the synergy between serotonin, a lot of people will say, well, you must have low serotonin because you're not producing enough melatonin sometimes. And I think that's where a lot of the confusion will reign for a lot of people. But typically, when it gets dark, you will produce more melatonin. And the effect of that is that it will suppress thyroid physiology. It tends to cool the body down. It tends to restrict thyroid hormone conversion. So one of the reasons why, from a circadian profile, TSH is often at its highest early in the morning, around about 1 or 2 a.m. And that's because darkness is at its peak, melatonin is at its kind of peak, and that carries on for a bit. And so that's one of the reasons why we're producing potentially more TSH in that time. Now, if you think about that from a seasonal aspect, it's been well documented over 100 years that typically TSH is produced least during the summer periods when there's more sunlight around. Why? Because we generally produce less melatonin. And long days of summer usually equate to more optimal production of other hormones like testosterone and progesterone and all of the other beneficial organizational and anabolic hormones. But in darkness throughout winter, it's a double whammy of the long days of darkness, also the decreased body temperature that comes with winter as well. You might say, well, people are wrapped up in clothes and they go home to warmer states, but there's still a lot of people who are kind of exposed to cold, and the body does get colder. And so therefore the increase to thyroid and thyroid physiology is usually backed up by an increase in the stress response by the pituitary production of TSH. So you see issues like seasonal affective disorder, low mood states, depressive-like states tend to occur in these longer days of darkness. There are even quite a few studies that suggest that subclinical hypothyroid states can occur in a lot of people that tend to resolve with the onset of spring, increases in longer days of light. So there does seem to be a very well documented effect of long days of darkness, less temperature, less light, increasing a low energy, low thyroid state that seems to resolve with the increases of daylight. And that's why, doing simple things like if you're in bed and you're cold, wearing socks on your feet can help to decrease the stress because your body doesn't have to work as hard. But equally, that can have an effect on how many carbs you're consuming and other factors.
Okay. So I'm trying to decipher that. And are there general guidelines that you kind of set aside during those winter months that kind of mitigate that kind of downward spiral?
I think it's really kind of looking at the markers that we've talked about. Temperature and pulse can be really, really useful. Looking at sleep states, mood states, digestive states, all of these are valid markers to see if you get that. I've had friends say that, they suffer from seasonal affective disorder and they tend to have responded reasonably well to getting more light. So it can come back to context. It might be a lack of light for someone that's driving that. And light might not just be wrapped up in thyroid physiology. It might have other connotations to other aspects of function as well. But if your body temperature and your pulse start to decrease during these colder times, it might be that you might need more thyroid hormone. You might be pushing yourself into a subclinical hypothyroid state that requires thyroid hormone supplementation. You might find that it might even be vitamin D that has an effect on things like immune system as well. So looking at temperature and pulse can help to clarify whether the thyroid's a key driver in that or not.
Okay. That's really interesting. So another topic that I've kind of looked into as far as your work goes is that of metabolic flexibility. Can you kind of go into what that is and some of the details around it?
Sure. So I kind of think about function is that we should have a certain amount of flexibility to deal with stresses. So we should periodically, even in the aging body, going through aspects of having slightly high blood pressure or also blood glucose values or, different aspects of function that don't appear to correlate with what some people might be normal. Having this flexibility is something that we should have. So if we bring it back to, say, energy intake and, say, glucose regulation, going long periods of time for some people would have been something that's relatively normal to do. When we didn't have an abundance of food, during the winter months as well, there would have only been certain types of food available. So it would have been normal for us to have this flexibility to deal with those stresses. It's a bit like fasting. Some people say, well, should you fast? It's like, well, you need to look at that. Is there even a need to fast? Because biology functions at its most optimal when there's adequate energy available. If you want to fast, because I think fasting, for example, is great for people that tend to overeat. If you're kind of someone who tends to overeat in emotional situations and you want to use calorific restriction and your body can cope with being able to restrict food. But a lot of people don't have that flexibility. So when they start fasting, mood goes out the window. They're more anxious because they're producing a lot of the stress hormones. Their blood glucose, there's plenty of cases where you've seen people fast and it's induced diabetes. You've seen plenty of keto. I've seen studies where people on long-term keto diets for epilepsy have gone hypothyroid. And that's an example of where their metabolic flexibility is not enough to entertain these kind of nutritional interventions. So it's like some people can fast, but whether they should fast is dependent on their metabolic flexibility. And what seems to be apparent these days is with large exposures to environmental pollutants, the best way to keep your liver functioning is to maintain its metabolic energy, which will give it most flexibility to adjust to energy losses or to stresses and to be able to respond to these stressful situations. I think a lot of people have lost that metabolic flexibility. And this is where regular eating comes in to help to restore that flexibility. So within programs, I often start with eating 5 or 6 meals a day. That doesn't mean they have to stick with that for life. They might be going back to 3 square meals a day, or even 2 big meals a day, with a snack in between, depending on the person. But it's usually that loss of flexibility, which means that they dip in and out of the stress responses, which they can't handle. So they end up producing all these excess levels of adrenaline, cortisol, glucagon, noradrenaline, because they don't have that metabolic flexibility. And when you start to see lack of inflexibility metabolically, this is where you start to see increases in blood pressure. You start to see these pre-diabetic states, which I don't like to use that term much, but I get a lot of people who have been defined as pre-diabetic because of their bloods, which are usually just a presentation of metabolic inflexibility, inability to use carbohydrates, altered aerobic system biology, and all of the other markers that tend to come with it.
Okay, so do you find that one of the key regulators of this is the inability to store glycogen within the liver and stabilize blood sugar over a suspended period of time?
Could you say that again? Sorry.
Do you think a key regulator of this is the ability to store glycogen in the liver and sustain blood sugar over a sustained time?
Yeah, I think that's probably one of the most important markers is the ability to use that. The brain, for example, uses a vast amount of glucose, and the brain will always ensure that the body preferentially saves enough glucose available, and it's obviously stored in the liver as glycogen. Now, the problem is that when people are exposed to high levels of fatty acids, pollutants again, the liver tends to become saturated with fatty acids, and this non-alcoholic fatty liver disease can often be an expression of high unsaturated fats. Thyroid physiology seems to be a key player in non-alcoholic fatty liver disease, and therefore, if your liver is sluggish, it might be coming from the food choices, the environment you're in. But again, key is thyroid physiology, and it's well noted that if the liver is flooded with the unsaturated fatty acids, it does tend to show more damage. Now, if you're eating obscene amounts of fat, whether it's saturated or unsaturated, high-fat diets do seem to create damage to the liver. Now, if your thyroid is dysfunctional, your ability to utilize fat and obviously carbohydrate is substantially diminished, and therefore the liver becomes the reservoir and the buffer. And this is where we start to see the problems with triglycerides flooding within the blood. We start to see loss of carbohydrate metabolism. When there's high fatty acids around, we see loss of the carbohydrate enzyme pyruvate dehydrogenase, which is lost as well. So it's important to understand that the liver is key in stopping the effects of the stress. And if the thyroid is dysfunctional, the liver will be dysfunctional. There's high excess fatty acids, the liver will be dysfunctional, and its ability to store glycogen and provide glucose for the brain is substantially diminished for sure.
What are some of the biggest tips that you give to someone to kind of help their liver relearn how to store that liver glycogen and use it appropriately?
Sometimes it's if you've been having a hard time with if you've been restrictive of carbohydrates, or if you've been in a stress response, a lot of people find that going quite high carb when they've been in that response, the ability to utilize carbohydrates is often diminished. So it's often worth going with small amounts of carbohydrate, with smaller amounts of fat and adequate protein. So I usually think it's not for everyone, but usually playing around with macronutrients. So always going with something 20% or less of your intake from fats, around about 40% carbs and 40% proteins is usually quite useful for people, because the less fat there is around, the less it's not so easy to go into eating excess amounts of calories. But again, playing around with that carbohydrate ratio can be key as well. But ensuring that you get adequate carbohydrate, a little bit of fat, and adequate protein can be helpful for liver function, not stimulating the insulin response too much, and just spreading the meals out over the day can be particularly useful, because it helps you not to produce insulin, not to produce the stress responses if you're not eating for longer periods. So regular energy intake is one. Using some of the pro-oxidative nutrients like caffeine can be useful. Making sure that you get adequate salt within the diet to stop you producing excess amounts of adrenaline as well. That can be particularly useful. Adequate light can be useful again, because you can make sure that you don't produce some of the stress hormones, which includes TSH as well. So TSH tends to stimulate things like fibrosis in certain tissues. I'm not sure if it stimulates fibrosis with the liver, but it certainly does with other tissues, and stimulates some of the cytokines like the immune responses, like interleukin-6, which is just one of the interleukins that can be problematic from a general body function as well. So if you can keep the stress responses down, which include TSH, you can have a more beneficial outcome for the liver to function as well. The other thing that would be to do is, I think, water quality. Staying away from fluoridated water can be particularly useful for thyroid function and for liver function. Making sure that the water is relatively clean. I hate to use the term clean, but it's probably the most useful word to use when it comes to water, because many water sources do tend to have a lot of pollutants still in. So that can be helpful. Air quality can be useful as well. I often get clients to do a checklist at home. So if they're living in a really polluted area, making sure they've got air filters at home, which can help to lower the burden that the liver's going through as well. Getting enough nutrients, and looking at some of the perhaps the pollutants that are bringing into their own home as well can be useful. Checking off, cleaning products, because all of this can create a burden that for one person they can deal with, but another person might be breaking their back, that's sending them back into a spiral again. So again, it's being quite contextual with someone, but trying to tick off lists of all the things that might be problematic for them from a thyroid and liver perspective.
Awesome. Well, I want to be respectful of your time, so I think I'm going to stop with my questions there. Where can people find some of your work and get a hold of you?
Sure, my website is balancedbodymind.com. My Instagram account is Tommo Littlewood, and that's pretty much it. It's got all the information on the website and the services that I offer. So thank you for giving me a shout out in time.
Definitely. Thank you for coming on.
Pleasure.
Thanks for listening, guys. If you're not in the Facebook group, make sure to get in there. We have a ton of people killing it on the ThermoDiet, and I will talk to you next time. Have a good one.